Your tool cache is working perfectly until the server updates its tools and suddenly your client is out of date. The solution isn't polling, it's listening. We'll implement a tool cache handler that automatically clears its cache whenever the server's tool list changes, ensuring your client always has fresh data without manual refreshes. The pattern uses FastMCP's built-in notification system to react instantly to server-side updates. From FastMCP client messages, import message handler. Import MCP, types. Class tool cache handler, message handler. Def init self. Self cache tools equals. Async def on tool list changed. Self notification, MCP, types, tool list change notification. To none. Clear tool cache when tools change. Print, tools changed clearing cache. Self cache tools equals, hash force refresh on next access. Client equals client, server, hi, message handler equals tool cache handler. This demonstrates the observer pattern through a specialized message handler system. The pattern creates a clean separation between event producers, the MCP server, and consumers, your application logic, where notifications about system changes are pushed to registered handlers. What makes this distinctive is its asynchronous, type-safe approach to event handling, where each notification type gets its own dedicated method signature. The system works by establishing a contract between server and client through predefined notification types. When server-side changes occur, like tool list updates, the framework automatically routes typed notifications to matching handler methods, eliminating manual event dispatching. This design leverages Python's type system to ensure handlers receive properly structured data, while the async nature prevents blocking during event processing. This approach solves the common problem of stale client-side caches in distributed systems. By reacting to server-initiated change notifications rather than polling, your application maintains consistency with minimal overhead. The pattern is particularly valuable in tooling ecosystems where plugins or extensions frequently change, though it does require handlers to be aware of all relevant notification types up front. Let's break it down line by line. From FastMCP client messages, import message handler. This imports message handler, the base class for processing FastMCP notifications. It provides the async callback infrastructure needed to react to server events like tool changes. Import MCP, types. Imports the MCP type definitions, enabling type hints for message handling. This ensures type safety when processing notifications like tool list change notification, preventing runtime errors from invalid data structures. Class tool cache handler, message handler. This defines a message handler subclass for FastMCP notifications. It inherits from message handler to process server events, specifically tool list changes in this implementation. The pattern enables clean separation between notification handling and business logic. Def init self. This is the constructor method that initializes a new tool cache handler instance. It sets up the empty cache tools list, ensuring the handler starts with a clean state before processing any tool changes. This follows Python's standard initialization pattern for class instances. Self-cache tools equals. This clears the tool cache when tools change. It forces a fresh fetch on next access, preventing stale data. This is the reset on change pattern for maintaining consistency. Async def on tool list changed. This defines an async event handler for tool list updates. The async def signature enables non-blocking processing of notifications, crucial for maintaining responsive server behavior when tool configurations change. This follows the observer pattern, where the handler reacts to external state changes without polling.
Self-notification, MCP, types, tool list change notification.
This parameter declares the message handler expects a tool list change notification payload. The type annotation ensures FastMCP validates incoming messages match this notification type, preventing runtime errors from malformed data.
None.
This is a Python type, hint, indicating the function returns nothing. The none annotation explicitly declares the method's void return type, which improves static type checking and IDE support while making the API contract clear.
Clear tool cache when tools change.
This docstring documents the cache invalidation strategy. When tool lists change, clearing the cache prevents stale data, ensuring subsequent requests fetch the latest tools. It's a defensive pattern against inconsistent state.
Print, tools changed clearing cache.
Debugging aid. The print statement confirms the cache clearing event fires when tools change, helping verify the notification handler works as expected. In production, this would be replaced with proper logging.
Self-cache tools equals hash force refresh on next access.
This clears the cached tool list when changes are detected. By resetting to an empty list, it forces a fresh fetch on next access, ensuring stale data is never used. This is the cache invalidation pattern for maintaining consistency.
Client equals client, server, pi, message handler equals tool cache handler.
Instantiates the FastMCP client with our custom message handler. The tool cache handler processes tool list change notifications, ensuring the cache stays synchronized with server updates. This is the standard client initialization pattern for custom message handling. Message handling pattern. FastMCP's message handler class provides fine-grained control over server notifications, letting you respond to specific events like tool list changes without processing every message. The cached tools list reset happens asynchronously, so ensure any dependent operations properly await the refresh. This pattern keeps your client responsive while maintaining clean separation between notification handling and business logic.
The handler that listens to everything hears nothing until it forgets what it knows.